Today our topic is process management. Under the process management, there is a subtopic. That subtopic name is process scheduling. Our objective is that our operating system should be multi-program. That is, simultaneously many programs should run. But suppose CPU, that is central processing unit, or our processor is only one. So using that processor, how to achieve multi-programming technique? Obviously, we have to ensure that our processor should run multiple programs at the same time. But practically, it is not possible. But how it is achieved? We all the time we have noticed that, as for example, here in this case we are running the Zoom, as well as we are running the Word, we are running the MS Paint software, and so many processes running simultaneously in our computer. So this is the example of multi-programming. But how it is achieved? It is achieved through the process scheduling. What are the different objectives of process scheduling? Before going to the objective of the process scheduling, some term that we have to remember. As for example, first term is turn around time. Turn around time. So what is the meaning of turn around time? Turn around time means when a process will be given to processor, and that processor will give the output by executing that process. In between the time is called the turn around time. Number two is throughput. What is throughput? Throughput means how many processes is executed per unit time by the processor is called the throughput. Next is the waiting time. Waiting time means a process is waiting in the ready queue for how much time. This measurement is called the waiting time. And you know that all the processes that are ready to be executed are stored in a queue is called the ready queue. So in the ready queue, a process wait. This waiting time is very much important. That is how much time a process is in the ready queue. Number four, response time. Response time means when a process is submitted to processor, and first when the process is starting to give the output. In between this time is called the response time. That is submission time and the first output given time. This subtraction or this difference is called the response time. So these are the some terminology that we have to remember. And what is the objective of process scheduling? Our objective of the process scheduling is that to make the processor all time easy. That is, never our processor will be in idle mode. All the time it should run some process. That is our objective. Now, in the ready queue, suppose many processes are waiting. As for example, suppose P1, process P1, process P2, and process P4 waiting. It is a ready queue. Now, how to how to manage the time given to the CPU? That is, which method or which process will get time for the CPU? Whether P1 will get time first, or P2, or P3, or P4. That is determined by some algorithm. So there are some algorithms are there that can be adopted by operating system to take the decision, that is which process will be given to the processor to run. So there are some algorithms are there. First algorithm that we are going to discuss is the first come, first serve. First come, first serve. This is an algorithm where we can describe it in this way. As for example, in this example, we have taken 4 processors. So here I am creating a table. Suppose I am creating a table. Here, suppose I am giving the process name. Here I am giving the suppose bus time. Bus time means total execution time. Okay. Here process P1, process P2, another process P4 that I am going to add. Another process is P4. Now suppose some bus time, that is execution time for each process I am giving here. Suppose this is 8 millisecond, it is 4 millisecond, it is suppose 9 millisecond, it is 5 millisecond. Okay. So that time I am giving. So now in the first come first serve means the process which will request first to be executed by the processor will be given time first. So here if I suppose P1, so P1 has come first, then P2 has come first, then P3, then P4 in this way. Here, so if the time start from 0, then we can say that P1 is taking total time 8 milliseconds. So here 8. Now P2 will take time for the 4 milliseconds. So it is here suppose 8 plus 4 means 12. Yeah. Now P3 will take 9 milliseconds. So 12 plus 9. 12 plus 9 means 21. Then P4 will take 5 milliseconds. So here it will add at the 26 milliseconds. Okay. So average waiting time for each process is what? Average waiting time. Here in this algorithm, average waiting time is what? For the P1, for the P1 waiting, how much time? P1 waiting 0. P2 is waiting how much time? 8. Then P3 waiting how much time? 12. P4 waiting how much time? 21. Okay. So it is divided by divided by 4 because total 4 processes are there. So 8 plus 12 means 20. 41. 41 by 4 is equal to 10.2 millisecond. So here average time taken for this algorithm is 10.2 millisecond. Next, another algorithm that we are going to discuss is the shortest job first. shortest job first. This algorithm we are going to. Shortest job first means which algorithm will take minimum burst time will be given first chance to be executed by the processor. So shortest job here, which is taking the shortest P2, then P4, then P1, then P3. So P2, P4, it will be P2, it will be P4, after that P1, then P3, P1, then P3. P2 is taking time, P2 is taking time 4 millisecond. 0, it is 4 millisecond. Now P4 taking time 5 milliseconds. So 4 plus 5 is 9. P1 taking time 8 milliseconds. So total here 17. Next P3 P3 taking time 9 milliseconds. Means here 26 millisecond time. Now here in this case we are finding the average waiting time. Here average waiting time is equal to time P2 is waiting how much time? 0. P4 P2 is sorry, at first I am telling P1. P1 waiting how much time? 9 millisecond. P2 is waiting 0. P4 waiting 4 millisecond. Sorry, P3. P3 is waiting 17 millisecond. And P4 waiting 4 millisecond. Divided by what? It will be total. It is 30 by 4. 30 by 4 means 7. Okay. So here average time changed. In this case, it is 75 milliseconds, but previously in the first come first step, it was 10.2 milliseconds. Next algorithm. Just along with the addition to the shortest of fast, we can add the another parameter, that is the shortest remaining time fast. Shortest remaining time. This term, shortest remaining time first. Shortest remaining time first. So what is the meaning of this? Another algorithm. This is the algorithm 2. This is the algorithm 3. This is the algorithm 1. Shortest remaining time first. Shortest remaining time means at first P1 first time is 8. So at first P1 will come. At first here P1 will come. Let's delete this, delete this, delete this. So P1 will come, but when P1 will be executed, before that, here we have to add In this algorithm, we have to add the another parameter that is called arrival time. Arrival time. Suppose some arrival time here I am giving here. Just a minute. Arrival time here, suppose I am giving 0, then 1, then 2, then 3. That is when these processes is coming to the ready queue, by what time later it is coming. That is called the arrival time. So P1 has come, but when P1 executed at the after 1 second, suppose P2 has reached. So as P2 has reached and P2 has been need the minimum time, because if 1 second executed, P1 executed for 1 second. So 8 minus 1 means 7 millisecond time remaining for the P1. 7 is greater than 4. So P4 will execute it fast. So P1 will be preempted. Preempted means it will be stopped. Actually, there are two type of scheduling. One is called the preempted scheduling, another is called the non-preempted scheduling. Preemption means stopping. In this example of fast come fast serve, in the example shortest of fast, here we have seen that these are the non-preemptive scheduling algorithm. That is, here we are assuming that no process will be stopped until it is finished. But in the shortest remaining time fast, we are assuming that this is a preemptive algorithm. Preemptive means here any process can be stopped in middle. Okay. So here P1 is stopping at which? At 1 second. Suppose at 1 second we are stopping it. It is 1 second, suppose. Okay. Now P2 is taking the P2 is taking 4. It is 4. But you can note that P2, when P2 executing, at the same time P3 is coming. But P3 will take the more time than the P2 to be executed. So P2 will not be stopped. P2 will be executed, continue to execute it. And also P4 will come at the time when P2 is executing, but still P2 need the less time to execute. So P2 will be not printed and not stopped, and P2 will be executed. Okay. Then P4 will be executed because P4 need the less time than the P3. So P4 will be executed. P4 will be executed, and P4 need, here it will be 4 plus 1 5. P4 need 5 millisecond time to be for bus time. So P4 total 5 plus 5 means here it will be 10 millisecond when it will finish. Okay. Now you can note still P1 executed only for 1 millisecond, but remaining time is what? For P1 remaining is 8 minus 1, that is 7 millisecond, and 7 is less than 9. So at first P1 will execute at its remaining time, then P3 will be executed. Okay. So P1, here it is P1 remaining time. P1 will execute in its remaining time. P1 will be executed in its remaining time. Remaining time is 7. 7 milliseconds. That is 10 plus 7 is 17. and here P3, only last processor P3. P3 will take 9 millisecond. So 17 plus 9, 26. It is 26 millisecond time. Okay. So here we are finding average time, average waiting time, average waiting time is equal to. So average waiting time for P1, P1 here it is 10 millisecond and 1 millisecond already executed. So here for the P1 it is 10 minus 1 plus for the P2 waiting time is 0 because 1 is the arrival time. See, arrival time for P2 is 1 and after 1 second it is coming. P2 is arriving. So 1 minus 1, that is 0 for the P2. P2's waiting time is 1 minus 1, that is 0. For P3, P3 waiting time is 17 minus its arrival time. 17 minus arrival time. Arrival time for P3 is 2 milliseconds. So 17 minus 2 plus P4 arrival, P4 waiting time is, here it is 5. So 5 minus P4 arrival time is what? P4 arrival time is 3. 5 minus 3 divided by 4 because total 4 processes is equal to 10 minus 1 means 9, 9 plus 0 plus 15 plus 2 by 4. By 4 is equal to 26 by 4 is equal to 6.5 millisecond. See, here drastically changed. The average waiting time here 6.5 millisecond. Previously it was 7.5 millisecond, and in the first come first serve it is 10.2 millisecond. Now another algorithm is priority scheduling. Priority priority scheduling. So what is priority scheduling? Priority scheduling means here priority will be set for each person. Suppose some priority I'm giving. Here priority I'm giving, suppose priority I'm giving. Suppose here priority I'm giving 3, then suppose priority I'm giving 5, then I am giving the priority 1, then giving the priority 2. Priority 1 means highest priority, priority 5 means lowest priority. So highest priority process will get time first for the CPU. So this, if you follow this algorithm, that is a priority scheduling, then what will happen? Yeah. So at first P3, then P4, P3, P4, P3, P4, P1, P2, P3, P4, P1, P2, P3, P4, P1. according to priority basis. So P3 is taking how much time? P3 taking 9 millisecond. 0 to 9. P4 taking how much time? P4 taking 5 millisecond. So 9 plus 5, 14. Then P1 taking how much time? P1 taking 8 millisecond. So here 22. And P1 8. Then P2. P2 is taking 4 millisecond. 26. Now, same way, we are going to find the average waiting time. In this case also, average waiting time for for the P1 waiting time is what? 14 millisecond. For the P2, it is 22. For P4, sorry, P3, it is 0. For P4, it is 9 by 4 is equal to it is 23 means 5, 45, 45, 45 by 4 is equal to 11.2 milliseconds, suppose. Okay, this priority scheduling sometimes good, but this type of algorithm, if you apply this type of algorithm, then your system may suffer of the starvation. Starvation means suppose lower priority process may never get processor's time. Okay, lower priority thread, infinite time it may wait in the ready queue, and never it will get time for processor. Okay, this situation is called a starvation. So in the priority scheduling, this may happen. Next, fifth, round robin algorithm, scheduling algorithm. Round robin scheduling. Round robin scheduling. Now in the round robin scheduling, what happens generally? Suppose here it is the process name, first time, first time. Suppose three here in this example I am taking three processes, P1, P2, round robin scheduling. And here bus time, suppose here I am taking bus time, here I am taking bus time, suppose 10, here bus time taking 3 millisecond, here bus time taking 3 millisecond. Now what will happen? Here a time slash is used. Time slice is used. Suppose in this case, we are taking the time slice as, suppose here slice I am taking 4 milliseconds. So 4 millisecond I am taking. 4 millisecond means each process will get time only 4 millisecond. Within that 4 millisecond, if any process can finish its job, then okay. If it is not finished, it will be rescheduled again. A small time quantum. Time slice means a small time quantum is used for each process. A process can execute only up to that time quantum. If within that time quantum, if it finishes its execution, okay. If it is not finished, again it will be rescheduled. This technique or this process is used in the case of round robin scheduling. Now P1 process is the bus time is 10. So it will be given time maximum. So P1 will get time for 4 milliseconds. 4 milliseconds. Okay. After that, it will be stopped. So remaining time what? 10 minus 4. 10 minus 4 means what? 6. 6 millisecond remaining. 6 millisecond here remaining. But it will be stopped. P2 will come. P2 will come. And P2 needs only 3 milliseconds. So it is within 4 milliseconds. So fairly it will execute and it will finish its job. So 4 plus 3 means 7. Next P3. P3 also can finish its execution within this time slice. So P3 also need 3 milliseconds means what? 7 plus 3, 10 milliseconds. Now no other process, only P1 remaining. P1 already 4 milliseconds has been executed. So remaining is 10 minus 4, that is 6 milliseconds. So 2 times P1 will run. 2 times P1 will run. Here P1 will run for 4 milliseconds. 10 plus 4 means 14. And another remaining time is what? See, 10 minus 4 means 6. 6 minus 4 means 2. So another 2 millisecond it can execute. Then it will finish. So 2 millisecond, no problem. It is within the 4 millisecond. 4 millisecond is the time slice time. So 4 plus 2 means here it is 16. 4. Here P1 is taking time what? It is 4 plus 4. 8 plus 2, 10. Total 10 millisecond elapsed for the P1. So no other process remaining. So here average waiting time is equal to, for the P1 waiting time is what? Here P1 is waiting how much time? See, already taken 4, so 10 minus 4. 10 minus 4. 10 minus 4 for P1. P2 waiting time is what? 4 milliseconds. And P3 waiting time is what? 7 milliseconds. Is equal to 10 minus 4 means 6, 6 plus 4 means 10, 10 plus 7, 17. 17 by 4 is equal to 4.2 something millisecond. 4.2 millisecond. So this is the round robin scheduling. So in this class, we have discussed different scheduling algorithm. That is At first, we have discussed the first come, first serve scheduling. Next, shortest of first scheduling. Shortest remaining time first scheduling. Then priority scheduling. Then round robin scheduling. Also, we have discussed some terminologies in process scheduling: turnaround time, throughput, waiting time, and response time. Thank you.